Hello everyone, welcome to the code space. In the last OS class, we have discussed about the scheduling algorithms and we have discussed FCFS algorithm. And in this video, we are going to learn the SCF algorithm and the remaining primitive algorithms. So let's start with the FCS algorithm. As the name suggests, SCF algorithm is used for scheduling the programs in the order of their burst time. It, in the process present in the ready queue, it selects the process which have the less burst time. For example, if we have three processes like P1 with burst time 3 and P2 with burst time 4 and P3 with burst time 2, then the CPU will schedule the process number 3 first. Then after it will continue its execution with process number 1 and then process number 2. So here the process with least burst time among the processes present in the ready queue will be selected first. The moment a process is selected, it will be keep on executing until a process with least burst time than the current process arrives. This is how the algorithm follows. And next to that, we have the another type of algorithms that are primitive algorithms. Primitive algorithms are mainly divided into there are three types of algorithms. First one is round robin, and then we have shortest remaining time first SRTF, and then priority scheduling. Let's discuss about round robin. Now, while coming to the primitive algorithms, a process can be preempted. That means it can be deallocated by the CPU at any time, even if the process is not executed completely. This nature helps in achieving the high responsiveness and reducing the starvation of the process in the ready queue. In the round robin algorithm, we maintain a time period called as quantum time T, and a process that is being executed by the CPU stays in the CPU execution more than the time t, then it will be deallocated, making sure that the CPU's execution will be CPU's control will be traversed through all the processes without starvation. For example, if we take a process like with process 1 here and we take the quantum time equal to 2, then the CPU will execute the processes in the same order of their arrival, and it will execute the first process for 2 seconds. then the second process for 2 seconds, and then the third process for 2 seconds, and then again it will come to the starting point and execute P1 for the remaining seconds, that is 1 second, and P2 for 2 seconds. In this manner, the round robin will execute the entire process, making sure that the responsive time of each process is less as possible. The next one is shortest remaining time first. In this algorithm, we select the process which has shortest remaining time, that is shortest burst time. And if a process is already executed for 2 seconds, a process of 4 seconds burst time has already executed for 2 seconds, then we'll compare the remaining 2 seconds. So we named it as shortest remaining time first. It will choose the shortest burst, least burst time process among the ready queue. The main difference in the shortest remaining time first and the shortest job first is the process can be preempted here. When a process with least first time than the remaining time of current process. This is the main point. Let me just increase the size. And the last process scheduling algorithm, that is priority scheduling algorithm. This is similar to SRTF, but it the preemption will be happen based on the priority. Like we'll have some priority tasks like opening an application, opening a WhatsApp application or a YouTube. These process are higher priorities than the process running in the background, like managing the memory slots, etc. So the moment a process with highest priority comes into the ready queue, the current process will be preempted out of the CPU and the process with highest priority will be executed. Choose the process with highest priority. A process can be preempted when a process with highest priority enters into the ready queue. So this is all about the preemptive algorithms in which the process can be preempted without even executing the complete entire process. And by this, we have successfully completed the CPU scheduling algorithms. Next, we are going to start about inter-process communication. Inter-process communication is the way in which two processes can be communicate each other. Like it can be by means of a common variable. Like if two programs uses a common variable, then these two programs are said to be in communication with each other. Like if two processes does not share any variable, then they are said to be independent processes. Consider a process. Like there are two types of processes. One independent process, independent those processes which does not communicate, and the other types of processes are coordinating, which shares a common variable or resource. Like now, in the context of multi-programming, if two processes communicate which are in coordinating, two processes are coordinating with a common variable can cause data inconsistency or a data loss. Sometimes it can also cause deadlock. So, to prevent the operating system from these problems, we use the concept of synchronization. Synchronization is the process of executing the process independently to avoid conflicts in the shared resource. And lack of synchronization can cause data loss and data inconsistency. this is the importance of the synchronization. And I hope that this is more than enough for today. And in the next class, we are going to discuss the necessary condition for the synchronization problems to happen, and we'll see some of the techniques to achieve the synchronization in the process. I hope you like this video. Thank you for watching.